Hello everyone. Today's topic is invertible function. I have seen so many times that the students are having some problem with this topic, which is invertible function. So let's try to understand this one in an easy way. So let's begin with the definition. A function f from x to y is defined to be invertible if there exists a function g defined from y to x such that g composition x is an identity function and f composition g is also an identity function. The function g is called the inverse of f and is defined by f inverse. In other words, we can say a function f from x to y be 1 1 and onto both, and if fx is equal to y where x belongs to x and y belongs to y, then f inverse y to x defined by f inverse y is equal to x is called an inverse function of f. Now, let's take one example, and with the help of that, we will try to understand that why it is necessary that if f to be an invertible function, why it must be 1 1 or onto both. Why, if the given function is not 1 1 or onto, and if any one of them is not there, why we will say that the inverse of that function will not exist. So for that, let's take one example. Let's say there is a set A whose elements are 1, 2, 3, 4 and 5, and set B whose elements are A, E, I, O and U. A function is defined from A to B, f from A to B in this manner that one image of 1 is A, image of B is E. Similarly, images for 3, 4, 5 are I, O and U respectively. Now, if we try to define a function g from B to A, that is, we are trying to define the inverse of the given function, then why we are saying that if f is not 1 1 or onto, if any one of the condition is not there, then we will say that this g will not exist. Why we are saying this thing? Let's try. If we are trying to define a function g from B to A, now if A was not 1 1, I'm sorry, if the function f was not 1 1, then what will happen? We know by the definition of 1 1 function that for no two values of x, there should exist a same image in y. Let's take one example. If we are saying that this was not the condition, instead of this, if we are defining like this, and we are saying that this is the set A, B, 1, 2, 3, 4 and 5. Here we are writing A, E, I, O and U. And we say that for 1 this is A and for 3 this is also A, and likewise this and this. Then when you will try to define from here to here, from this side like this, then what will happen? For A, there exists two images, one image is 1 and other image is 3, but the definition of function says that for every value of x there must exist a unique image in y if for any value of x there are more than one y, then that will not be a function. So this is the condition why we are saying that f must be 1 1, because if f will not be 1 1, then when you will go to define, when you will try to define g, that will not be a function, right? Now the second case, if this f is not onto, let's take one more example. If this is A, this is B. Now if we are saying that 1, 2, 3, 4 and 5, and here A, E, I, O, U, let's say P. Now if we are saying it like this, now when you will try to define function from b to a, that is when you try to define function g, when you try to define function g, what will happen when you try to define function g in this condition? You will not get any image for this element p here. Then what will happen? For every value of x, there must be image in y, and corresponding to this p you will not get any image. In that condition, what will happen? Again, this g will not be a function, therefore this g will not be defined. That's why we are saying that if a function f has to be defined from x to y, has to be invertible, in that condition f must be both 1 1 and on 2. Now the thinking process, how to start the question. So let's start step by step. Step 1, check that function f from a to b is a bijection. If yes, then we will go for the step 2. Otherwise, if it is not a bijective function or it is not a bijection, then we will conclude that f is not invertible. And in the step 1, if you are getting that f from a to b is a bijection, then we will start solving further. Then what will we do? We will start with the step 2. We will put fx is equal to y, where y belongs to b and x belongs to a. Then step 3, solve fx is equal to y and get the values of x in the terms of y. Now the final step, put f inverse y in place of x and in the relation obtained in step 2. So this is the thinking process. Now we will take one example and try to understand that what we have to do in these kind of questions. So the example is, let f be a function defined from real number to real number, be defined by fx is equal to 3x plus 7. Then we have to show that f is invertible and hence find f inverse. So now the solution is, in the first step, note down whatever the value of fx is given. This is 3x plus 7 and f is defined from R to R. So if f is defined from R to R, so this R is the domain of the function and this R is the codomain of the function. Now when we want to check it that whether the function is 1 1 or not, so the first step for that, you will write let x1 and x2 be two different points. Now what we have to do, we will write f at x1, that is 3 times x1 plus 7, f at x2, that is 3 times x2 plus 7. Next step is, you will put f x1 is equal to fx2. So this will be 3 times x1 plus 7 is equal to 3 times x2 plus 7. This will get cancelled out. You will write 3 times x1 is equal to 3 times x2. x1 is equal to x2. Therefore, fx is a 1 1 function. Now we will check whether the function f is onto or not. So for that, the first step is, we will write fx is equal to y. Value of fx was given as 3x plus 7, so we will write 3x plus 7 is equal to y. Here the values of y are written in terms of x. Now we will try to write down the values of this x in terms of y. So what can we write? On rearranging, we can write it as x is equal to y minus 7 upon 3. Fine. So this we have got x is equal to y minus 7 by 3. Clearly y minus 7 upon 3 belongs to R for every y belongs to R. Now, for a function to be onto, there was a condition that function to be onto range must be subset of codomain. In this question, given codomain is R. R means real numbers. Now, from, let's say this is your equation number 1. Now from 1, x is equal to y minus 7 by 3. Now, what are the restrictions on y? If we try to find out that what are the restrictions on y, or what are the values that y can acquire. So y can acquire any value from minus infinity to plus infinity here. Since no value of y is in the denominator, so we don't have any restrictions, and r is given as, x is given as this. So if we try to find out the restriction on y, we will get from here, we will get that y can take any value from minus infinity to plus infinity. So this is range. This is the range. Now range is R. Range R, codomain, that is also R. So range is a subset of codomain. Therefore f is onto function. Now we have got that given function. Now we have shown that f from R to R is 1 1 and onto both. Hence, it is invertible. Now, what we have to do now, just replace f inverse y in place of x. So you will get, now we will get x is equal to y minus 7 by 3. This was your equation number 1. Now substitute f inverse y in place of x. So this will become f inverse y is equal to y minus 7 by 3. That is f inverse x is equal to x minus 7 by 3. This is the inverse of the function. I hope all of you have understood the concept clearly. Thank you so much. Have a good day.